Good afternoon, everyone. I am Suraj. Here's my Discord name. You can visit the website, and you can look at these slides if you want. You can just go to this link and you open up this presentation. And the accompanying code is also here, so you can open. Alex talked about this being the hardest data science tournament on the world. How about making it even harder with Numerai signals? With Numerai Classic, you get free data, normalized data, prepared data. But how about them asking us to get our own data and then submitting signals? So signals is about submitting a prediction about the stock market, or to be precise, ranking these stocks in 0 to 1. So it's sort of converting those all sorts of signals, or like text, numbers, images into a ranking, also a relative ranking of stocks. So what's the goal with signals? It's to first monopolize intelligence, so like get the best intelligence data, monopolize data, get the all sorts of data in the world, data that's not available to Numerai that we can submit using signals tournament, monopolize money, it's like being the only hedge fund that the world needs, and then decentralize the monopoly on these crowdsourcing features. So you can think of signals as like crowdsourcing features instead of another tournament. So you collect your data, you make your models, you make predictions, and those predictions are then combined. But here the change is like we bring our own data instead of we using their data. So there are some correlations with the classic one, which is the metrics. The scoring metrics is immense correlations. So the higher your correlation between your signal and the actual market, the higher your returns are. Neutralization also happens here. So we don't want, Numerai don't want the signals that are repetitive, what they already have. They don't want those. They want unique signals. So neutralization is like a way of removing the linear component from your predictions to what they already have. So it's like neutralization. Targets are like neutralized 20-day returns, so 20-day return forward returns. The structure is same. It's like relative ranking of stocks in quantile form. The data splits. So we have historical targets. It's like training, validation, and live. And the metric are similar as discussed. Correlation is like Spearman's correlation. FNC is feature neutral correlation. TC is, you can sort of think of it as a feedback on your stake. Should you increase your stake or should you decrease your stake? Eventually it does like, it increases your contribution in the meta model or reduces it. Are you helping the meta model or not? And yeah, how it's different. So in Numerai Classic, we have no idea of what the data is. It's like all things anonymized. Here they have a universe, like they say, we want predictions for these specific stocks in the market. You bring your own data instead of using their own. We generate our features and submission. Unlike Classic, where you have to make predictions on all the stocks, all the rows in the live data, we can just submit predictions for 10 stocks. You can just send a list, like these are the ones that I like are going to up, and these are the ones that are going to go down. Yeah. So what are the targets? How do these targets look like? So it's just like a relative ranking. Here you can see 20-day target being 1 means we want to long those stocks, so we want to buy it. On 0 means we are going to go short on these, so we don't want that. 0 means we predict these stocks are going to go down. 1 means we're going to go up. And what sort of data that you can use to make those predictions? This is a standard candlestick pattern, which you might have seen in the stock portfolio apps like close, open, low and high, OHLCV as you call it. It can be textual data, fundamental data like earning history, reports, and all those stuff. options and futures data you can combine, or any type of data that you can convert into a ranking. That's what we want. It can also be words like to the moon, only go up, and then like worst quarter in 3 years, something like a Wall Street bets subtract. You can also look at that and convert a signal out of it. So for textual data, you can look at the news, tweets, Wall Street bets, discussions. And then once you have those words, like sentences, you can convert them into a numerical representation, like using a pre-trained sentiment model, or like you can train your own language model on top of this. That we'll discuss in the next presentation. So once you have those numbers from those words, you need to rank them. So you can then learn a mapping from a model that learns the mapping from these numbers, the embedding representation into targets. And then you can just repeat them. So here's an example that I built using Wall Street bets data to predict the market. And you can see here the transformed signal is sort of a leading indicator for the market. So like this went up before the market went up. So like sometimes it catches up. And here's another example where Carlo used Finbert to extract more better signals out of it. So this is just textual data. Another is using OHLCB data, the price data that we see, like how much the stock moves in a day. The idea is to get high quality sources. Yahoo is one source. Generate feature, convert these time series of data into a tabular format. Something that I like to do is transform it into a classics format. So we have like features, targets divided into different eras or like days. And then I can just use the same script that I used for classic on these signals. So something like this. So it would be something combined in a row cross column format. We have dates, tickers. It's like one day has like 4,000 tickers, so it's the whole stock market, and the price data, the close pricing. So we can group that, then transform it into like a stacked date eras, or that's what we call. Like you can see here, 1,600 stocks, 2 columns, price tickers, almost 3,000, 2 columns, price tickers, and then this is the era component, and then we can use feature generation. We can use like simple moving averages or time series. We can convert these time series. We can extract these statistical features out of these time series to convert it into a format that we want. It could be something like all these are technical features: exponential moving average, RSI, MFI, MACD, crossovers. This is an interesting one. Volatility. So all those statistical features. So here's how it looks like. This is for Apple, 1 day chart. So this is EMA crossing. So EMA for 10 days and 20 days. We can extract these using Python, and we can use it. So after extracting those features, this is how it looks like, and we can see how the 18 million rows that span across 2003 to almost like last year, 2022. Each day, each trading day, 5,000 stocks. So this is sort of a big, huge amount of data. And these are just 50 features that I've extracted. 10 features. But this is not a standard form. This is like some stocks have higher values, like the actual value, $20,000. Some have currency difference, like one could be 20,000 in Indian rupees, or another could be 300 in USD. So how do we solve that? For that, we just rank them. So to handle those cases, we use crossovers. So we are removing the absolute values, and we are taking sort of a scaled relative difference between these momentums. So that sort of handles those currency differences in Numerai. And we need to scale these data to feed to the model. So we can use Z-score. We can use min-max scaling for like group day to day. We can use percentile transformation. Just need to be careful that we are not looking at future prices when we are calculating it right now. And to transform it into a classics format that we saw in previous presentations, we can use like quantile-based discretization. So it becomes from random numbers to something like this. Rand between 0, 1, 2, 3, 4, 5. These are 5 quantiles. And this also spans from 2003 to 2022, about 18 million rows, 11 columns. And now we just need to attach targets. Like we have created those features, we have extracted them, scaled them. These are tickers. And after attaching target, it is very similar to your classic model. So all your tips and tricks that works in classic are now applicable here. And we build a model. It's just like XGBoost is all you need. So this is just a basic model that we can use. We just pick this basic model. And we can backtest it on validation. So we train on train split, and we can do some sort of backtest on validation. So I would like to give you a walkthrough of the notebook. Can you see? Yeah. Yep. Here's the libraries installations. We are using a library called Open Signals, which lets us download all this Yahoo data for free and save it. These are the tickers that we want, which we want in the live tournament about 5,000 tickers. We want to make predictions for. This is just data downloading. This is how the raw data looks like. Open, high, low, close, adjusted prices, volume, currency provider. You can see like 0 volume. So Yahoo has some errors in the data. So this is just for the example. After cleaning and like scaling it, we get some split adjusted data. This is what one day looks like. So like on 18th, 9, 2022, this is just like a snapshot of one day, like top 10. For this, we have about 4,759 tickers in the data, unique tickers, historically spanning from last 20 years. Technical indicators created RSI, SMA, simple moving average, exponential moving average, and MFI. And I added some parallelization so you can train, like generate these faster. And I'm generating it for 14 days, 21 days, these frequencies. After generating this, we have this, I call it level 1 data, that is extracted features from these time series, grouped into days, and we can visualize that. So how is it going? So like SMA 7, SMA 21, EMA, close prices. And what I call this is the secondary features. This is the relative difference between these frequencies. So instead of comparing prices between two different countries, we are comparing the difference between the two momentum. So like we are looking at the relative difference rather than absolute values. So we use these features to generate these features, and then we scale it in the range 0 to 1. So yeah, that, and we now merge targets. The targets are on like this sort of distribution. Most are 0.5, some are 0, some are 1. So there are less extreme values and more min values. And for modeling, it's just like feature selection. So we are looking at like how much a feature is correlated to each target. So we can see that the most correlated feature is EMA 7 minus close. So it's like ratio between EMA on 7 days divided by close prices. And this is the number of tickers. As you know, this is like correlation plotter. The full training data set, like it has training, validation split, all the features, about these many rows and these many columns. After attaching the targets, the training is XGBoost, prediction distribution. This is a locally scoring metric. So on training, this model is doing like 4% correlation on average with a Sharpe ratio of 1.7. Sharpe ratio is something like mean divided by volatility. So we want higher mean, so we want higher returns over each day. But the volatility between those predictions should be low. So we want higher Sharpe. So on training, it's saying it's hitting positive on 96% of the day. This is on validation, it's about 0.5. So there can be a survivorship bias because we are using 4,000 stocks only, but historical universe it could be 30,000 stocks, but this is just to show that when you add more stocks, the performance could go down or it could improve as well. And here's the submission file that you can upload to the website to evaluate your predictions, actual predictions. This is the feature importance of each feature if you want to filter out the least important ones. And you can upload this. After uploading it, it looks something like this. So FNC V4 is feature neutral correlation. So after removing the linear exposure from existing features that Numerai has from your predictions, this is what on average looks like. It has FNC V4 of 1%, correlation, straight correlation of this is what we look for, it's like 1%. Max drawdown of 16%. So max drawdown is how much a stock, your prediction can go from the top to like the most it can lose in one go in a sequence. So no, it's like use quality data. You have to use quality data. The valuation bias is when we select the stocks that we have today only. But historically, there could be some stocks that existed but then got delisted. We also want to look at them. The currency difference. You can't straight compare Indian stock worth $20,000 to US stock worth 20,000. Indian stock in 20,000 rupees to US stock in $200. So that you have to like look at that as well. You can also submit raw features. Instead of making a model, you can just combine your features and submit it. It just have to be a ranking. No machine learning needed. There are more than 50 model slots, so you can like, train and test all sorts of models, features, strategies, and get those evaluated. The best thing is to do backtest a lot, cross-validation, and you can test your models without actually training yourself. You can just submit, see how it's performing in the market, and yeah, you can. And now there is a chance that there is a possibility you can upload a portfolio straight instead of just ranking. You can build your portfolio and get it evaluated in the live market. There is something that I was working on called signal select. So the notebook I showed you, it takes a long time to like load the data, generate those features, make those predictions on all historical data. So I wanted something that can use those previous calculations, save it, and just calculate the latest features. So with signal select, the goal is you should be able to set up entire pipeline within few hours using free or paid resources. Use pure Python, no dependencies, easy installation, and yeah, It should be runnable in Colab in default runtime, so less on compute. You can run on your laptop as well, so that the whole signals light, but it's still in working product pipeline. So yeah, this is something I'd like to introduce you to. And what's next? You can look for other indicators in the notebook. Try different modeling techniques, so like XGBoost. We now have more targets and signals as well, so you can like assemble them, like GPL, neural networks, linear models, whatever you like. You can, Rocket Chat is no more. We moved to Discord, and forum is a nice place to learn about it, and now Peter's Wiki. Check out Numerai. So let's say you don't have those pipelines, and you want to buy someone else's predictions. So there's like a secondary marketplace that you can buy those predictions that someone else is selling. You could just straight submit, or you can just buy predictions from 10 different well-performing models that they are selling. You can combine them on your end and submit it. Office hours videos on YouTube helps a lot, and a new round has started. You can just load the notebook and run it, make your first submissions. Here are some resources, and this is the link for the slides. You can go this, load the notebook, run it, and see how it goes for yourself. That's all. Thank you. Any questions?
You mentioned Yahoo Finance in this one. Yeah. What other data providers, if any, have you been using in your experience?
There's another called EODHD, endofdayhd.com, udhd.com. That costs about $20 a month. So I'm using that one. Previously, I used to scrape all the Wall Street bets data, some news providers' data, and then create sentiment models on top of that. But it was taking a lot of time, so I just like scraped it. I know. Currently, I'm using only the price data using UDHD and Yahoo combined. So.
Cool. Thanks.
Thank you. Any other questions?
It's a time.
Thank you.